What should we do first to solve our equation? Remember, we want to isolate our radical, so get everything else besides the radical to the other side. So what should we do?
Add 6.
6 is being multiplied to that radical. So what's the opposite of multiplication? Division. So we would divide negative 6. So the square root of n plus 4 is equal to, what's negative 60 divided by negative 6? 10. Now how can we get rid of that radical? Square it. So whatever we do on one side, we have to do on the other. So we square both sides. So it cancels out on the left, and we just have n plus 4. And what is 100 squared? 10 squared is 100. What should we do next? Subtract 4. So then we have n is equal to, what's 100 minus 4? 96. And that's our answer. And we can always take our answer and plug it back into the question to check our work, if you wanted to, if you had time. You can always check your work that way. Any questions on that one? All right, let's take a look at number 3. What should we do first? Divide by 3. So we have x minus 2 to the power of 2 over 3 is equal to, what's 12 divided by 3? 4. Now how can we get rid of that exponent? Raise it to the reciprocal. So 3 over 2, 3 over 2. What happens on the left side? It cancels. So then we just have x minus 2 on the left, and on the right we need to figure out what 4 to the power of 3 over 2 is. What's our index here? 2. So we have the square root of 4 to the third power. What are 2 factors of 4? 2 and 2. So we would circle our group of 2, take that out. So 2 to the third power is what? 8. 2 times 2 times 2 is 8. And then what should we do next? Add 2. So x is equal to 10. All right. Number 5. We need to sketch the graph of the function. So we're going to plug in values for x. That's a good question. So one way that we can tell if our graph's going to decay or grow, so if it's going to have exponential decay or exponential growth, without graphing it, is we can always just look at the number that x is the exponent of. If that number is less than 1, so less than, then it's decay. If the number is greater than 1, then it is growth. So there might be some questions on the quiz where it'll give you an equation and say, state if it has exponential growth or decay. You don't even have to graph it. All you do is look at that number that that exponent applies to, and that'll tell you if it has growth or decay. So here, do we have exponential growth or decay?
Decay.
Decay. Since it's 1/2, that's less than 1, it is decay. But let's graph it, because we'll probably have one on the quiz that you'll have to graph. So we're going to plug in numbers for x, get values for y, and then put it on our graph. So what should we plug in for x? -1. So we have 4 times 1/2 to the power of -1. What does that -1 do to the 1/2? What happens when you have a negative number as your exponent? you would put it under 1. We flip the fraction. So if it's a whole number, it becomes a fraction. You would put it under 1. If it's a fraction, you'd make it a whole number. So this would become 2. Because we just flip it to become 2 over 1 now. So a negative exponent flips the fraction. So 4 times 2. And what's 4 times 2? 8. So we plugged in negative 1 and we got 8. So we go to the left to negative 1 and up to 8. So that's our first point. What should we plug in next? 0. So we have 4 times 1/2 to the power of 0. What's 1/2 to the power of 0? 1. So 4 times 1 is what? 4. So we plugged in 0 and got 4. So there's our second point. What should we plug in next? 1. So we have 4 times 1/2 to the power of 1. What's 1/2 to the power of 1? 1/2. And what's 4 times 1/2? 2. So we plugged in 1 and got 2. And then next we can plug in 2. We have 4 times 1/2 to the power of 2. 1/2 to the power of 2 is like 1/2 times 1/2, so that would be 1/4. So we have 4 times 1 over 4. What's 4 times 1 over 4? 1. So we plugged in 2, so we go to the right 2 and up 1. So once we have our 4 points, we can draw our curve there. Look, our graph has exponential decay because we're decreasing, so we knew that from the start. We hit exponential decay. We know we put our points in the right spots too because we said it was going to have decay just by looking at it. So let's take a look at number 7. The first year of a charity walk event had an attendance of 400. The attendance Y increases by 5% each year. How many people will attend in the 10th year? Round your answer to the nearest person. So we have 2 formulas for our word problems. We have A is equal to A times 1 plus R to the power of T. And then our other one is A is equal to PERT, so P times E to the power of RT. We use A PERT when it says compounded continuously. I think I spelled it wrong, but it says compounded continuously. We use our PERT formula. If it doesn't say that, we use this one. So it's number 7. Doesn't say compounded continuously, so we're going to use our first formula here. So we need to find our A, which is our starting amount, our R, which is our rate, but in decimal form, and T is our time. So what's our starting amount? 400. What's our rate?
0.05.
Awesome, 0.05. We take 5% and move the decimal 2 places, so that would give us 0.05. And then what's our time? 10. So we plug it in. We have A is equal to 400 times 1 plus 0.05 to the power of 10. So according to our order of operations, what do we need to do first? The parentheses. So 400 times 1 plus 0.05 would be 1.05. And then to the power of 10. So we just did our parentheses first. What should we do next? The exponent. So we have 400. We need to put 1.05 into our calculator. So 1.05 do that little x raised to the y button, and then 10, and then equals. So we get 1.628, and then more decimals, but we're going to keep it in our calculator to make sure our answer is as exact as possible. And then our last step we need to do is multiply that times 400. What'd you guys get for A?
Wait, so how do you get that number? What do you do? That's for
The exponent here. So we put 1.05 in your calculator. You have x to the power of y, so that button there, and then 10, and then equals. So this is just how you put it in the calculator. What'd you guys get as your answer?
651.557.
Awesome. 651.557, but it says round to the nearest person, so we're rounding to the nearest whole number, so 651, or we could round up to 652. They'd both be right. So, yeah, it'll tell you what to round to, but like I won't take points off if you're like one number away. But if you like rounded your answer here and you were like 20 people away, then your answer would be wrong. All right, let's take a look at number 9. The population of a small town was 3,600 in 2015. The population decreases by 4% annually. What will the population be in 2025? Round your answer to the nearest person. So we're going to use, it doesn't say compounded continuously, so we use our first formula. So we need to find our starting amount, our rate, and our time. So how many people do we start with? 3,600. What's our rate? 0.04, but it says decreases, so it'll be negative 0.04. And then what's our time? 10. It doesn't tell us 10 years, but it says we go from 2015 to 2025, so 10 years. So we need to plug everything in. So we have 3,600, and then 1 minus 0.04. So because it says decreases, we have to put that minus there. So just got to be careful with that. And then our exponent is 10. So what should we do first? Subtract. So we have 3,600. 1 minus 0.04 is 0.96. What should we do next? The exponent. So we do 0.96. Click that x raised to the y button in your calculator, and then 10, and then equals. So we have 3,600 times 0.6648. So we put this into our calculator by clicking 0.96, x raised to the y, 10, and then equals. And then we keep it in our calculator to be as exact as possible and multiply it by 3,600. What did you guys get for this one?
2,393.397.
Awesome. 2,393. It says to the nearest person, so we're just going to leave it at the whole number of people. So here. All right, let's take a look at number 11. An account earning 3.9% interest compounded continuously for 10 years would have a balance of how much if the principal was 500? So compounded continuously means we're going to use our PERT formula. So we have to find our P, our R, and our T. What's our P? Principal. What's for number 11? 500.
Oh,
What's our rate?
0.039.
Awesome, 0.039, because we just move our decimal 2 places, so we need to put a 0 in front of the 3. And then what's our time? 10. So we plug everything into our PERT formula, so A is equal to P, which is 500, times E, raised to the power of R, times T. What should we do first? The parentheses up here. So 0.039 times 10 would be 0.39. What should we do next? The exponent. So we're going to put this into our calculator. In your calculator, when it's E, you do the number, so 0.39, and then you click that E raised to the X button, and then it just solves it for you. So this is how you put it in the calculator. So we get A is equal to 500 times 1.476, and then it keeps going. But we're going to keep it in the calculator to be as exact as possible. What's the last thing we have to do? Do what? Multiply. So we just multiply by 500. So we have 738, and we're dealing with money now, so just 2 decimal places, so 0.49. That's our answer. Any questions here? So if you use e to the power of x like this, you have to put the number first, but if you use the e, so a different way to put this in the calculator would be if you click E, and then you have to click that X raised to the Y button, and then you do 0.39, and then equals.
Can I answer that?
Yes.
I don't get it.
Okay, let me pull up the calculator and show you.